Welcome back to Vuln Vibes. In this episode, we're going to talk about Apache Tomcat vulnerability. The Apache Software Foundation has just delivered, well, a pretty critical set of security patches for Tomcat versions 9, 10, and 11. And this isn't just one flaw we're talking about. It's really a triad of risks. We're going to dissect 3 distinct CVEs today, and they really cover, the fundamental spectrum of failure points you see in complex middleware.
Exactly. Yeah, we're not looking at just one attack vector. It's more like 3 different flavors of failure here. You've got a failure of logic in the core routing engine. That's the one leading to potential remote code execution. Then there's a failure of operational awareness, basically an injection vector targeting the admin console itself. And finally, a more subtle failure, it's in resource management, which can lead to a denial of service condition. For the professionals listening, folks running these stacks, understanding the technical depth is key. And critically, the context for the RCE vulnerability, the fact that it's a regression that's essential for really assessing the risk accurately.
That structural view definitely helps organize the triage process, doesn't it? Let's jump straight into the highest priority risk then. CVE-2025-55752. This is the big one, flagged with potential RCE implications. But what's interesting, as you mentioned, is it's not brand new. The advisory tags it as a regression, stemming from an earlier fix for bug 67003. So for our really technical listeners, let's unpack the anatomy of this. What exactly went wrong? What was bug 67003 trying to do? And how did fixing that break something else?
Well, what's fascinating here is how close they were, only to kind of reverse the security logic in the process. Bug 67013, that was originally filed because Tomcat needed to tighten up its access control validation, especially when dealing with URL-encoded non-standard characters in request URIs. The whole point was to ensure path components were properly processed before they hit sensitive application constraints.
Right, so it was an effort to stop attackers using things like double encoding or weird characters to sneak past security checks.
Precisely. The original fix tried to solve that, but yeah, it introduced this sequencing regression, specifically in the URL rewrite module. The core issue, the real heart of it, is that the rewrite engine started processing the rewritten URL by applying normalization before it decoded the characters. This specific order reversal normalization prior to decoding, that's the entire vulnerability right there.
Ah, okay. And if you swap those two actions, normalization then decoding, that creates a window, doesn't it?
Yeah.
An attacker crafts a URI with encoded path traversal bits like URL encoded dot characters, and these bypass the rewrite security checks meant to protect those important directories.
Correct. The system normalized the path first, but because it hadn't decoded the malicious characters yet, the security mechanism just didn't see it as dangerous traversal logic. Then, once it was normalized, the decoded path still had the ability to sidestep those critical access control layers. We're talking about the layers shielding sensitive directories like WINF and meta-INF. You're essentially tricking the internal routing pipeline.
That's a classic fence post error, that kind of logic failure, just applied to how URIs are handled. But hang on, getting from a directory bypass to actual RCE, that usually requires a very specific setup, right? You need to exploit this to actually deploy a payload.
Yeah.
How does that leap happen?
Yeah, it connects directly to resource manipulation capabilities, specifically through HTTP PUT requests. So if an attacker can use this URI manipulation flaw to get access to a location, and if the Tomcat installation happens to be configured with PUT requests enabled, which might be for, say, operational deployment or resource management, then that malicious file could potentially be uploaded directly into a sensitive directory that Tomcat executes from.
Wait, hold on a sec. If the RCE is really contingent on such a rare non-standard configuration, enabling PUT requests and having a specific kind of URI manipulating rewrite rule, why is Apache flagging it as the most severe? Are we maybe over-indexing on the theoretical worst case here? Shouldn't admin time maybe focus more on, say, the DoS condition, which might be easier to trigger?
It's rated severe because the impact is maximum full RCE. That's the worst outcome. But your point about prioritization is spot on. The advisory is quite clear. Exploitation needs this specific, non-standard combination of settings. But let's think about why an admin might have this config. Sometimes in CI/CD pipelines or maybe automated deployment setups, PUT capabilities are enabled to automate resource placement. Or maybe in some legacy environments, a PUT request handler is just still lurking around. So if you have, say, custom deployment script that uses a rewrite rule to redirect traffic internally, and it's coupled with automated file acceptance, well, then you are definitely in the danger zone. It's definitely a low probability, high impact kind of vulnerability you absolutely need to patch regardless. But the risk profile for a standard hardened installation is certainly lower.
Hey, that operational context is really vital for modeling the risk properly. So for the security teams listening, let's just confirm the affected versions and the immediate patch targets. The affected ranges are pretty wide here. Tomcat 11.0.0 M1 up to 11.011 and 10.1.0 M1 up to 10.1.44. And finally, 9.0.01 M11 all the way up to 9.0.108. The immediate mandate is to get to 11.0.1, 10.1.45, or 9.0.109.
Yeah, that upgrade is absolutely non-negotiable for mitigating the RCE risk.
Okay, let's pivot now. We've talked about the failure of core application logic. Let's move to our second vulnerability. CVE-2025-55754. You frame this as a failure of operational awareness. This is a console ANSI injection flaw, and it shifts the attack surface away from the web stack itself and more towards the person actually managing it.
Exactly. This is a really fantastic example of how you can achieve a subtle client-side attack, but initiated through server logging. Basically, Tomcat failed to properly sanitize or escape ANSI escape sequences. These could be hidden inside logged request parameters, like in a malicious, specially crafted URL. So it doesn't attack the server directly, it actually attacks the system administrator who's viewing the logs in their terminal.
And the condition for this to work is quite specific, isn't it? This mainly hits Tomcat instances running on Windows environments where the console actually supports interpreting these ANSI escape sequences. But I suppose you could mount similar attacks elsewhere if the terminal emulator is set up to interpret them too.
Precisely. Think of ANSI escape codes, like invisible instructions for your terminal for formatting, colors, etc. An attacker crafts a URL containing these codes. When the server logs that URL, the terminal doesn't just display the raw code string, it executes the instruction. Now, this could do harmless things like change text color, but the real danger is it can also send control codes to the terminal emulator itself. Things like potentially clearing the screen, messing with the scroll output, or, and this is the critical part, manipulating the administrator's clipboard buffer.
Seriously? You mean I could actually get pronged just by having my logs open in a vulnerable terminal environment? Wow, that's like old-school terminal trickery combined with modern web vulns. How does hijacking the clipboard actually lead to RCE on the admin's machine?
Well, it relies pretty heavily on social engineering and the admin's typical workflow. Imagine an administrator is debugging something. They copy a legitimate safe command, maybe systemteld or restart tomcat.service from somewhere else, ready to paste it into their console. But the attacker's invisible ANSI sequence, which got logged just moments before, has silently injected a malicious payload, perhaps a regit command, to download malware into the clipboard before the admin's intended command. So when the admin pastes and hits enter, thinking they're running their safe command, they're actually unwittingly executing arbitrary code provided by the attacker, all triggered by just one log line.
That reliance on the operator, just assuming their own terminal environment is safe, that makes this deeply insidious. It weaponizes trust in your own tools and the log output itself.
It really does. And Apache's warning here is crucial. While Windows consoles supporting ANSI were the main identified vector, they explicitly say similar manipulation attempts may have been possible to mount on other operating systems. It really depends on the specific terminal emulator and its configuration. It just highlights that operational security isn't only about hardening the server processes, but also hardening the entire administrative workflow, including the tools you use.
Right. Well, thankfully, for this ANSI injection flaw, the patch levels needed are the same as for the RCE fix. That makes the maintenance window a bit cleaner, at least. You need to ensure you've applied those 11.0.1 and 2.1.45 or 9.0.109 updates.
That's right. One set of patches handles two quite severe, though fundamentally different, attack vectors.
Okay, let's move to our final CVE for today, 2025-61795. This covers the third failure category you mentioned, a failure of resource management. This one results in a denial of service condition through resource exhaustion. Sounds less glamorous than RCE, maybe, but it can be just as devastating for system availability. What's the scenario that triggers this particular DoS?
This is a subtle one, yeah, but it's a critical failure in how temporary files are cleaned up during multi-part file uploads. We often see vulnerabilities around file upload size limits themselves. Here, the flaw happens when a user tries an upload, and that upload triggers an error. The most common case would be exceeding the configured file size limits.
Okay, so the system does its job. It correctly aborts the upload because it's too large or maybe malformed, but then a mistake happens right after that failure.
Precisely. The system created temporary copies of the uploaded file parts, and these can be quite large if an attacker is deliberately sending massive chunks. But instead of deleting them immediately and synchronously right when the error occurs, they were just left behind for the Java garbage collection, the GC process, to handle asynchronously later on.
Right. And for those maybe not living in JVM land every day, the garbage collector is kind of like the system's background cleanup crew, right?
Oh,
It runs intermittently, asynchronously, to reclaim memory and temporary resources that the application isn't actively using anymore.
that's a perfect analogy. And the core security problem here is that an attacker could potentially flood the system with trash, these massive, failing temporary files, faster than that cleanup crew, the GC, could possibly work. So depending on your JVM settings, memory pressure, overall application load, that dedicated disk space for temporary files could get filled up much, much quicker than the GC process can clear it out.
And once that disk space is full, especially the partition holding the temporary directory, the application, maybe even the whole host OS, can't create any new necessary resources,
Right.
which leads straight to a resource-based denial of service. Seems like a pretty good tool for a lower skill attacker, too. Just flood the endpoint with huge failing uploads and wait for the system to choke.
Exactly. It's an availability risk that's triggered entirely externally and, yeah, requires minimal sophistication to execute. It really underscores that resource efficiency isn't just a performance metric, it's a genuine security concern as well.
And listeners really need to pay close attention to the version numbers here, because they are slightly different than for the previous two CVEs we discussed. The affected ranges for this DoS run from Tomcat 11.0.01 up to 11.0.m1, then 10.0.0.m1 up to 10.0.109.
Yeah, notice how the ceiling, the upper end of the affected range, is higher for this DoS vulnerability. That means even if you patch for the RCE and the ANSI injection, say, you moved up to 11.0.11, you are still vulnerable to this DoS condition. So for really comprehensive mitigation from this whole patch cycle, you absolutely must push to the final patch levels given. That's 11.0.11, 10.1.47, or 9.0.110. It's essential to hit those final numbers.
Wow. Okay, so if we try and connect this all back to the bigger picture, this whole patch cycle really offers a comprehensive lesson in just how complex application security is. We've tackled three completely distinct attack surfaces, haven't we? A failure of logic in the rewrite engine allowing access control bypass, then a failure of operational awareness leading to, well, client-side admin console poonage, and finally, a failure of basic resource management resulting in availability loss.
It perfectly illustrates it. Securing a big middleware platform like Tomcat isn't about tackling just one layer or one type of flaw. It's about managing these intricate dependencies, external environmental factors like the admin's terminal, and even core operational cleanup procedures. For those of you managing fleet deployments, the message is loud and clear. Check those version numbers immediately. Every single patch in this cycle is mandatory.
So your key takeaway here should definitely be to immediately verify all your Tomcat deployments. Make absolutely sure you are hitting those final patch levels 11.0.12, 10.1.47, or 9.0.110 to get comprehensive coverage against all three of these flaws we've talked about today.
Absolutely. Don't leave those resource management issues, or any of them, lingering. Patch promptly.
And as we wrap up, here's maybe a final provocative thought for you to mull over, something to think about. Given that the most critical flaw here, CVE-2025-55752, was actually a dangerous regression. It resulted directly from an attempt to fix an earlier bug, bug 67013. What does this incident really tell us about the inherent fragility, maybe, of security fixes in massive, complex, open-source middleware like Tomcat? Does the fact that a fix actually broke security logic in a new way? Does that mandate an entirely new approach, maybe much more exhaustive security regression testing within your own patch deployment workflows, particularly around tricky areas like URI normalization and decoding pipelines? Think about how much testing surface just potentially opened up for you there.